Should I start?
Yes, yes, please. Go ahead.
Okay, sir. Uh,
Yes, Nabeel.
can you see the slides?
Yes, we can see.
Okay, sir. So basically, we want to do computational study of second harmonic generation in nonlinear crystals in ZEMAX. So basically, what is second harmonic generation? First, we'll try to understand. Second harmonic generation is basically a nonlinear optical process in which when an incident light interact with non-linear crystal, means the crystal having no symmetry, the frequency gets doubled or the wavelength get half. In other words, we can say that here, as you can see in the diagram, schematic diagrams of second harmonic generation, here we are using incident light of 1064 nanometers, and we efficiently converted into 532 nanometers in our experiment, but we want to implement the same setup using ZEMAX. So ZEMAX is basically an optical design software which is used to design different and multiple optical components like gratings, interferometers, and spectrometers. In our setup, we have basic light sources, which is 1064 nanometers. In ZMAX, we don't have any non-linear elements. So basically what we want to do is use both the wavelengths, 1064 nanometers and 532 nanometers as incident wavelengths. And then we are using a lens and a splitter just to check the incident power of the laser. It is a basically beam splitter, not a separator kind of splitter. And then we have a second harmonic generation crystal. But in ZMAX, we don't have any second harmonic generation crystal. So we are using a very thin layer, very thin material, thickness of millimeters, and we have applied the coating like birefringence on this crystal. Then a harmonic separator. Basically, our main issue is in ZMAX is second harmonic generation crystal and harmonic separator. Currently, in my setup, what I was using is a beam splitter, normal beam splitter, which is splitting the beam into two, depending on the transmission and reflection of the beam, and then a prism to further refine the output beam, and then there's a detector. Here is the lens data editor window of my setup, in which you can see a standard lens polygon object, which is used as a splitter, then lenses, and then detectors. The incident power which we have used is 1 watts, and this is basically the 2D and 3D layout of my setup, in which you can see here is the splitter which is splitting the beam, and then a lens to collimate the beam. And the second harmonic generation, it is not a non-linear crystal. It is basically a thin layer which have birefringence coating. So it is splitting the beam into ordinary and extraordinary rays, and then a lens, and then a harmonic separator. Right now, here the harmonic separator is not actually a beam, actually a harmonic separator. It is kind of a beam splitter, which is splitting the beam into depending on the reflectance and transmission. Uh, as I've discussed previous with Mudassir, it is not a harmonic separator. This was the main issue which we were discussing in the last our meetings and all. And these were the spot diagrams what I was getting at detector 9. Here's the one second. This one is the detector 9 and this one is the detector 10. And these were the power which uh, we were achieving. Like our incident power was 1 watts, and here you can see we the peak irradiance 7.632 and 2.732 watts per centimeter square, and the total power at the detector 10 is 6.59 milliwatts and 2.73 milliwatts. So basically this setup was designed in non-sequential mode of ZEMAX, and you guys know the limitations of non-sequential mode of ZEMAX, in which we don't have any kind of further results. So we have these kind of two kind of results. What I have studied, I can change this. What are my findings? I mean, I studied how to design some beam splitter. The possible solution I got is dichroic beam splitters. Dichroic beam splitters are the basically splitter which split wavelength, which split beams depending on the wavelength. Here are the basic sample syntax of these two. Basically, in the table file, we name the coating file. Here we are making uh, passing and stop filters of dichroic mirror and angle of incidence at which we want to split the beam. Here we have to add the both the wavelengths, like you can see, I have mentioned in our case, as the incident wavelength is 1064 nanometers, and we want to split the beam, uh, and we want to transmit the 1064 nanometers and 532 nanometers to reflect. So, yes, in the syntax, you can see here RS is basically reflection coefficient in S polarization, and RP is the reflection coefficient in P polarization. In here are, if you can see in our case, the coating file can be designed as 1064 nanometer beam will not be reflected, but it will be transmitted. As you can see, the coefficients I have added are 1 and 1, means it will be transmitted. And for 532 nanometers, both the it will be reflected, as you can see in S and P plane. And in case of, but for transmission, these are both coefficients are 0, so it won't be transmitted, it will be reflected. And to increase the transmission, we have used this another command, which is one transmission, which decides the transmission. This 99 means it will be 99% transmitted and 1% reflected. And here you can see in the diagram the actual geometry of dichroic beam splitter, which I found on ANSYS website. But right now, what problem I am having is I have designed this, I have made this data file, coating file, but the problem I'm having is I can't retrieve it. I can't open this coating file in my ZEMAX. Actually, I don't know if it is not suiting the software or something else, but it can be designed this way. If you have any suggestion how to open this file, basically the file has extension of DAT, uh, and I don't want to edit the ZEMAX catalog file, which ZEMAX already have. I want to add this coding file uh, manually. I don't want to edit the actual manual of the ZEMAX. So the problem I'm having is I can't add this uh, file in my setup, in my ZEMAX. If you have any suggestions how to add this coding file or how to retrieve data from this coding file in ZEMAX, you guys are more welcome.
Nabeel, first tell me, where do you want to use this die-crock beam splitter? In place of the
Uh,
conventional one?
Sir, wait, let me go to the previous slide. Here, at place of harmonic separator.
In place of
Basically,
harmonics? Mhm.
yes, it is not actually a harmonic splitter. What I was using is a beam splitter, which are actually splitting the beams into, let's say, 50% transmissive and 50% reflective. But a harmonic separator stops some wavelength and transmit other wavelength. So if I am using 1064 nanometer wavelength and 532 nanometer wavelength, at least I have to design this dichroic kind of beam splitter, which will transmit 1064 nanometer and reflect 532 nanometer. This beam splitter is splitting both the beams, like transmitting 1064 and 532 nanometer and reflecting 1064 nanometer plus 532 nanometer. What we want is that 1064 should be transmitted and 532 nanometers should be reflective. As I discussed with the Mudassir earlier, which Mudassir pointed out in discussion, that it is not working as harmonic splitter, but I have right now in my geometry. So we want to design this kind of, we want to add this kind of coding file, which will pass 1064 nanometer and reflect 532 nanometers.
So probably Mudassar can. What do you think,
Yeah.
Mudassar?
No, it's
Yes.
good. It's going fine. But the way he's trying to make it, it is very good. If we can make that, we at least we can uh, make a equivalent setup in which we don't have a second harmonic generation phenomena, but we can track down the two wavelengths, how we can separate them before the detector. So if we can make
So,
a harmonic separator, that is good. And the way it is working, we will see
so
once the sorry.
one moment. Nabeel, let me rephrase what you have told us. Like, you mean you are going making SHG, okay, with 1 micrometer wavelength initial, your parent wavelength, and then later the both beams are coming, and then you want to separate the both of them and measure the power of independent wavelength, right? That's the your logic,
Yes,
the main point.
yes, yes,
Okay.
yes.
So,
That's
so
what we want
why
to do.
why you want to like say it like the harmonic separator? Is the if like we can use dichroic mirror simples and the beam separator with the two coating for like one for transmission coating and one for reflecting coating. That's it. Like it can split both
Actually, sir,
wavelengths.
let me clarify.
Mm-hmm.
Basically, I'm using the same splitter, what you are suggesting, with the
The beam
same,
splitter.
yes, a normal beam splitter.
Okay.
But
Yeah, that's fine.
actually, we don't have non-linear components like second harmonic generation crystal. So I
Mm-hmm.
added a thin layer of a glass, you can say, and I applied a
Okay.
coating of birefringence, which is
Mm-hmm.
splitting the beam into ordinary as it happens in non-linear crystal. It
Mm-hmm.
splits the beam in ordinary axis and extraordinary axis, the two axes which we have in
Okay.
non-linear phenomena or birefringence phenomena. But the issue
Uh-huh.
was, if we don't have these two kind of uh, components in in ZMAX, then how can we say that it is actually near to the actual problem, or it is visualization of the second harmonic generation system? The beam splitter
You
here you
okay.
see is a simple beam splitter, which is splitting
Yes.
both the beams, let's say 50% and 50%, which is
Yeah,
not
yeah,
what a harmonic
it's
separator
happened.
does.
That's what I
Harm
am like saying. Once you have like the SHG, you have it like either it's not the nonlinear crystal, the green light let it say like SHG because we are using 1 micrometer and 532 is coming the green light. So once you have you will have like 1 micrometer, and then you will have 532.5 micrometer, right? So it means like you will have two beams, but they definitely we don't want them to be reflected by 50% with in the case of typical beam splitter. But we just
Yes,
want to
right,
separate
sir.
of how much the harmonic is generated and how much the main parent's beam is coming, right? Whatever the
Right.
portion we have, that is the case. So in
Yes, sir.
that case, like if in a dichroic mirror, like you have coating for like you have 532 coating with the coating of HR coating layer with the 530 nanometer, and then you the same mirror splitter with coating of high transmission coating of 1 micrometer. So that means when the beam falls, whatever the portion of like harmonics we have, that will be reflected, and the rest of the portion will be transmitted to this dichroic mirror. So that
It's
will be like
it's
Basically,
basically simply a splitter. When we have source beam and a
no,
second
like
harmonic, we want to separate
um,
them. Like
yes, that's what once we my point is once we put simple beam splitter, that's the Nabil what said it, like it split the 50-50%, like 50
both of the
half of
wavelength.
them is
Yeah,
both of the wavelength, right?
yeah.
So but when
But
we have a coating of both, okay, so it won't reflect it, like it will not reflect all the wavelengths, both of them, like at the half. Whatever the
yeah,
portion of one we have, it will reflect whatever type coating we have done for that particular wavelength. It will
yes,
yeah.
sir.
The
reflect
rest
that.
will be the other
Uh,
wavelength we transmitted. So we can simulate
Yes, that
that on the transmitted one, we will get one kind of wavelength, and and the reflected will be
exactly.
one. So
So
exactly.
that will
so
be
you better to
equivalent.
use dichroic coating, like dichroic
Yeah,
mirrors with the dichroic coating. That's you will
Actually,
good to go.
yeah.
pardon,
This
sir.
is what we are trying to make
Actually,
here,
we
basically.
don't have in my setup. I don't have dichroic coating.
Mm,
Okay.
This is the issue.
So that's what they
So
So I
want to
am
have
not
now.
sure. I am not
mm.
sure. Like, does the ZEMAX allow to? Because I haven't used this ZEMAX like things. I'm not familiar. Does
No,
ZEMAX
we are
allow
trying.
it? Like you can export the file with the dichroic coating mirrors, like any data file from other
if
some companies. They can be
if
exported to this.
it is properly, if it has proper syntax or in proper format, ZMax read that
Mm-hmm.
file. I checked that, I studied that. ZMax read that file. Like ZMax, the catalog ZMax is providing, that is DAT file. And ZMax read that DAT file. If the syntax are proper, we can add that coating in the ZMax catalog. So I
Mm-hmm.
want to add this dichroic coating kind of material, dichroic coating, which will stop what we say pass wavelength and stop wavelength coating,
Yeah.
like dichroic mirror. So if it works, we can have a dichroic splitter in place of ordinary beam splitter, which I am using.
Yeah.
As of
Okay.
my understanding, there are dichroic mirrors, like when you go to like some mirrors providing websites, they have provided their like ZMax files as well. So you can retrieve data from there, and then you can directly insert that file to your ZMax to add this dichroic portion for both. Have you seen that, like the websites of different companies which are providing the mirrors, like Thor Lab and others?
Thor
Uh,
labs have this kind of thing, but
yes.
the problem is they give you the data, basically the way
Most of them
the
they
beam
give.
is presenting. So we have to
Hmm?
put that
Please
data
try,
in a
please,
coding
please
file.
try one by one. Okay, don't overlap the
Mm,
comments. Please wait for the
yeah,
other
I
person's
mean,
comment and then please.
I'm saying
that's right.
that
That's right.
when we got the Thor labs, they give us the data, not the exact file. So when we get the data like the Nabeel is showing here, like angle and wavelength and transmitters, RP and RS values, they give us that. We have to put that data into a file, which is basically coding file, or there's some other file as well, but mostly I put the data in a coding file. When you place that data in a coding file, when you open a ZMax and go to the coding section, you will see the file or the data you have inserted with the name, the file you have given in within that file. So you can use like that. You cannot take the file directly from the Thor Labs and put it in the ZMax. This is a
I
limitation.
guess, I guess like to my like what I'm lens or mirrors using from the the Thor labs, they have their all the apart from the parameter data, definitely they
Hmm.
have provided whatever the parameters are there, they provide the data sheet, definitely. But like they
Yeah.
also provide the ZMAX in non-sequential mode, all the whatever the port mirrors they selling, they provide their solid works file, like the design file, different files they provide, okay, for
Yeah.
each and every component.
Hmm.
So
Okay.
is it like, if I understand it right, so if that file is available, because I'm not sure the mirror you have search for that have that file, a ZMX file over there, but most of Thor labs have the ZMX files. So you don't need have to put like data sheet, just directly put the data. You can like directly export that file, if I'm getting
Actually,
it right.
Yeah.
this is
That.
the issue I'm having, like integrating the file. What the
Mm-hmm.
company will provide, it will be the same DAT file with the same syntax. I have to
Oh,
integrate
okay.
that file in the ZMax. Basically, I'm having issue in integrating that file in the ZMax. The data sheet or something which will they will provide, it will be the same kind of thing, uh, like the same ZMax file, which you can see I have mentioned in our case what kind of coating or what kind of design we need. I have
Mm-hmm.
to integrate the same kind of file in ZMax. So I am
Oh,
having issue with the integrating the file, not retrieving the data from some source, Thor Labs or
Yeah.
ANSYS. I'm having the issue with integrating the file. Uh,
Okay, Nabeel. So
mm-hmm.
this is the problem actually.
Mudassar, I
So,
think. Mudassar, like, it can give inputs. I am not sure about this.
Mudassar, I
How to
think,
integrate this.
excuse me, Mudassar, I think Mudassar will not have experience about this kind of thing as well. Do you have?
Yeah. I just last time I put the you can say filter kind of thing. I tried. They already have a blue filter, so I tried to make a red filter. I applied that, but it was showing some issue. I integrated the file, but I just put the data into a coding file they already given. I give it a proper name. So when I open a ZMax and coding, I can see that file which I have inserted in the coding.
Actually, I
So
don't want to edit that catalog file which
yeah,
ZMax is providing. I don't want to edit it. Uh,
you can add it, then you can remove it. It will not create any problem. But just try to plot the thing the way they have placed there, so it will not create any problem. I tried, but I left for this purpose. I was just working, but the way that you are trying it, it's going good. You will see after looking for some time, you will get. But you have to be just careful that on one detector, when you simulate the one wavelength, you should get only one wavelength, and for the other wavelength you get an empty detector, not a single photon. Then we can say, yeah, our beam is splitting correctly. And
yeah,
the simulated
actually,
graph that you have simulated, these two are, it isn't giving any meaning, because the two simulated beam shapes, they have been simulated on a two different parameters. That's why they are just separated like that. If you
yes,
take
yes,
any kind of wavelengths, you can get the same kind of spot by just adjusting the, you can say, parameters. So we
yes.
have to need a empty detector for a one wavelength and a spot for a
Y-
other wavelength. Then we
Yes,
can say we are
actually,
separating.
you are right.
Yeah.
This is what I want. Basically,
Yeah.
we have the coating of 1.99, which transmits 99%, but still
Mm.
we have that 1% which we get on the splitters.
Yeah.
So the diachronic will solve this problem. It will only transmit one and reflect the other one. But
Yeah.
I will try to add this coating in the
Mm.
catalog which ZMAX provided.
Yeah.
And thank you for your suggestion and comments.
Yeah.
I will try
Okay.
to do that too.
Okay,
You can try it.
Nabil.
I will see them.
Okay, Nabil, thank you very much. So probably further, if you want, you can discuss with Mudassar privately.
Sure,
And
sir.
so hopefully the problem will be solved and you can have your third
Yeah.
paper. But one
Sure,
thing,
sir.
Mudassar, one thing you didn't mention here, the sequential
Mm-hmm.
and non-sequential.
Mm-hmm.
So he has few results. So that,
For sequential, at least if we can separate it, like we can make a harmonic separator. First we can separate it, then we will see if we can adds second harmonic generation crystal data if we get for a ZEMAX, and then we can integrate that as well. But first we have to look for a separator. If we some way separate the harmonics, then we can also try with the crystal as well, because for the crystal there must be a data given for a ZEMAX. But first we need a separator, so we can separate out, at least we have some equivalence with the actual setup. Result we can see, we can have in non-sequential mode, we can have around 8 to 9 result as well, but we have to, you can say, extract them out
One more
beside the
thing,
radius.
I want to add one more thing.
Mhm.
Actually, the issue with sequential mode is having problem with the splitter. I
Yeah.
mean, in sequential mode, the splitter geometry is not so simple as in the non-sequential mode. That's why I preferred non-sequential mode. In sequential mode, splitter is not designed like
Yeah.
this. It has to be like multiple surfaces, and we
Mm.
have to define each and every purpose of each and every surface. So it's not very easy task. That's why I preferred non-sequential mode.
Sequential mode is not for a splitting, basically. It's only for a one
Yes,
path of ray. You can follow
in
one path, not
some
two.
ray and some surfaces, like it's going straight through those surface.
Yeah, that's the point.
Okay. Okay. So thank you very much, Nabeel. And
Okay.
now, David, are you there?
Can I
Yeah.
show some data? I have
Okay. Okay.
make a
Okay. Okay.
presentation.
Go ahead. Go ahead.
Just a second. Where is this? Can you guys see the screen? Because
Yes.
I have
Yes.
a little bit problem in a Word. No,
Yes.
sorry, in a PowerPoint in this laptop.
No, it's
Okay.
okay. We can see.
Okay. Just let me see if it can go full screen. Yes, it can go. So now you can see that, I think. Oh, can you see
Yeah,
the
we can see it.
presentation?
We can see it.
Okay.
Yeah.
Go ahead.
Okay. Basically, I have tried with the Surfaya stuff. Initially, the file he has provided, I have some dig out something about the parameter they have just, you can say, we are looking for to how to enter those values. There are some values which we can enter, but some values we can left out there, like you can say the X super Gauss parameter. There is a given. This is basically depend on the profile shape. If we have a Gaussian shape, then it has one value, and if we have a Lorentz, so that we can find out from the shape of the beam, or either we can know if we know that, like pulse lasers are mostly Lorentzian, so we can put the value of like that. So there are some parameters which we can define, but some are which are just, you can say, from 0 to 1 you can guess it, or you can, if you want to find it actually, then you have to have like, you can uh, take the spectrum, and you can say the data sheets. But if you want to make it perfect, it's okay, but that parameter doesn't, I don't think so the system we have simulated has that much impact on them. But we will see, if we want them we can also put them, like by say looking at shapes, etc., like x width, y width, that we can define some x sigma values. You can also see that it's a standard deviation of Gaussian beam in the x direction. So that is, I don't think, is a measurable quantity. It may be in a data sheet, or you can left it, or you can guess a value that we have to see what is the range for this parameter. So we have to look for some parameters, but some we need, if we want to really want to put them there, so we need to have exact values. But you know, every parameter is not possible. Like if you have a spectrum, you cannot guess from it how much is spreading in x direction or y direction, so you have to be need a delicate system for that. So some value we can left out, but we will see them. The parameter, the file which I got from Surfayaz, I just modified it little bit, like I just keep the lenses, the distance same like this one, so that it's have a, you can say, symmetry, because when I look at it, I found they have a distance difference between the lenses. So I just work on a little bit, just little bit parameter I have changes, not much, we can see that. But at the final, I just finalize, try different thing, then I finalize this geometry for the system we want. This is basically if you put absorbing detector, so it will stop all the beam, or if you have a transmittive kind of detector, then the beam will pass out. So the final geometry, something 2D layout came out like that, and I just rotated to see if the beam is going anywhere outside this waveguide. So it was going through the waveguide. There was not a problem. When I simulated them, first I was a little bit confused to which parameter we have to simulate it. Like it has the incoherent irradiance values and coherent irradiance, which is basically a main parameter for us, or you can say main result for us in a non-sequential mode. So when I just simulated, this is an incoherent irradiance which is falling on the crystal basically. So when I simulate that, I got for the irradiance along X, like you can say this is the shape along X, I got something like that. We can smooth it out if we want. This is I got for the Y. I tried as much as possible by adjusting different distances or something, but I get best at somewhere some distance which I finalize, and when I simulate them, I got something like that. There is still little bit, you can say, not exactly, you can say symmetric. It has some peaks, so we can. I was basically not able to make it like smooth one, but we will see that. Then I just tried radiance in position space and radiant one. Then I tried to change the scale. I just, this is the linear scale. I just got the y-axis in the log scale. When I got to the log scale, this specs removed somehow, and it's giving us a like a uniform peak, like on every portion of the, you can say, crystal, the same intensity is falling everywhere. First thing. Second, there is a two option. One is the incoherent irradiance, second is coherent irradiance. First I was confused. There was because the laser is a coherent source, so I thought we might need to simulate the coherent source, but when I tried with the coherent irradiance, I always get spikes with a lot much amplitude for this y coordinated value. X was still a little bit, not you can say little bit, it was, you can say, a very noisy system. The reason is that when we have some interference phenomena at the detector, then we look for the coherent irradiance, like in a interferometry. When I was simulating the basically fringes, then for the coherent irradiance, I always get these kind of fringes, because there are two beams which are interfering, and at the detector we are seeing the phase difference between these two beams, so we get this kind of fringes. But if for the same detector in a you can say interferometer, when I simulated the incoherent irradiance, it came like that. It means the two beams are approaching, whether they are coherent, incoherent, but in coherent way they give us this fringe pattern, and incoherent irradiance means the light is just approaching the you can say detector. So we will get something like that depending upon the shape. I was getting a you can say rectangular or square shape source, so it give me like that on detector. So in our case, I found out we need to simulate incoherent irradiance, because we have one source, and the one source is traveling and it's falling on the detector. When you go to the detector at the center, basically the beam is traveling straight, so the phase is same. But when the beam is coming from above the side, like you can say from here, when it's moving right the down side, the distance that covering by these photons is little bit different in the center one. So that's why when we simulate the coherent irradiance like that, we never get a shape like that, because the beams are not coherent at the detector, because they have traveling the different distance. So we need to see how much light is falling on the detector, whether it is coherent, incoherent, that doesn't have anything to with us, because we are not checking any coherence phenomena or interference phenomena. So for that we need to check this in incoherent irradiance, and that what I have applied, and then I simulated these results. That were, for time being, I have got this for the non-sequential mode, and I'm working in a sequential mode, but there is a problem with the waveguide thing which I have not sorted out yet. But first I thought I should share with the Dr. Fayaz especially whether what he think about it, because we need to simulate, and the result he was expecting like that, and we need to simulate incoherent irradiance, because we are just following the light on the crystal, not we are checking any interference phenomena on the crystal. So we will never get a coherent irradiance pattern like that, no matter what we do with the setup. That is basically the Sir Fayaz work. So now I want Sir Fayaz and Sir Tayyab to what they think about this and how we should proceed it.
Okay, Mudassar, thank you so much, dear. Basically, this is like good of you. You're like done a good work. Like you find out this, you are totally right. That source is like at the detector, and we need to find out in terms of incoherence because like this is not a single source. When we are using single emitter, okay, then we can select a coherent. When we talk about a laser diode has like multiple emitters, like it can have 10, 20 emitters,
Yeah.
single laser diode bars. So in that case, it is always be incoherent. So you are right about that. It is always be incoherent. When we
Because we are
select
not
it,
checking the coherence phenomena. If we want to check the interference at the detector, then we get the like two sources, and then when they interfere, they will give us the some structure. But we are just following the light on the detector, so it should be incoherent, not a coherent phenomena on the detector.
exactly. And
Yeah.
second things like what the basic purpose was like to pump the beam to the laser crystal. The shape was like it should have the top head distribution along the horizontal direction. The one you like just simulated with the like flat top distribution, and the one with the Gaussian distribution. So this
Yeah.
is like the main purpose. Whatever the laser diode source in our laser source. So my question is like you have like once you one point you have sorted out like incoherent or coherent about thing which why we need to do it. Second, you was like confused about the waveguide thing if we want to convert it to the non sorry sequential mode things. So
Yeah.
like let me like just like describe this beam shaping system before I have told you like whatever we do with the waveguide, this is used to homogenize because like the laser diodes crystal, like the beam is coming with the divergence and they have some space with between each other, the beam part apart from each other. So we have to homogenize, and for the homogenization, we need to have multiple reflections inside a waveguide. So what
Yeah.
that makes it makes the it homogenize the beam when it comes out from the waveguide. So this is the purpose of the waveguide. So
Okay.
for that point, like in the literature and the people what have done, they have used the prisms things. They have used array of micro lenses. Okay, the one I'm going to talk about that if we could somehow simulate that micro lens array, it is kind of grating mirrors. Simple.
Yeah.
Okay, that is can be also be replaced in terms of from like from the they can replace the waveguide. So so this is the main purpose. No, just let me know this how much smoothing like you have added like 10, 5 in non-sequential in this like for incoherent source with this. Can you like
I
describe?
I think first I tried with the 0. Okay.
Okay,
So for that, I
they
was
have
getting the
noises.
x coordinated value was pretty much like that. It was good. It has not that much
Okay,
like a specs. For the
X
y
doesn't
coordinated
change.
value, I getting little bit of spikes. So I have just added
Okay,
smooth. I think it will be 20 or maybe max. I don't remember for these as well, but I have tried many one. But I have applied smoothness on them for
mm,
a y axis
that's
especially because it was not getting smoother.
so at this moment like what smoothing like 1%?
No, it will be 20.
20,
20.
okay, that's fine. No, no issue because like the margin of like intensity fluctuation of like in the top head distribution, that is why here our y coordinate. Because like
Yeah.
we are basically it's here is like bit confusion because we selected the x divergence as a y divergence and divergence as a x divergence. So that's why like x horizontal appears here as a y coordinate and vertical appear as x coordinate. So this is like
Yeah.
just like that's not critical here. So
Yeah.
no, I mean like smoothing is not a big issue. We can like go it with this 5% of intensity fluctuation still very much acceptable for this pumping distribution. Sorry, pumping of the laser crystal. So my second question is like you said like you just adjusted the mirror distance. Definitely that would be the way to go. So what was like the file I shared you
Hmm.
the intensity distribution in that one, and here you find the difference of like what had you done like
Yeah.
the distance and the manipulation of these because I guess you didn't change the parameters of lens like their focal length and other things. You only I mean manipulate the distance between these optics elements, right? Is that right?
Yeah. Basically, I
So,
just change the distance between the first two lens, basically,
okay,
and make it
okay.
exactly equal the distance between these the second pair. The distance between two lens to
The
lens
first
is
two pairs.
same. Yeah,
Okay.
first two pair.
So, right.
And then I just
Okay. That,
place the little bit. You can say move forward the waveguide according to that because the light was going out. So I just
yeah,
little bit
we
changes
can go
that
step
thing.
by step. Yes.
Yeah.
Like
Then I
point by
just
point.
first I
Mm-hmm,
just changing the distance between this. Okay,
mm-hmm.
I
Okay.
make this distance equivalent to the distance between these two so that there is symmetry. Okay.
Okay.
I j-
So that's fine. So this is clear. No, initially you talked about the values like delta x, hx, and delta y, x gauge, and y gauge.
Mhm.
Basically, in laser diode, I just want to add the information like for in laser diode, if like we have Gaussian distribution, we put gauge x. But if we have a
Mhm.
top distribution, flat top distribution, so it can be like from vary from 1 to 20, maybe higher than that value.
Yeah.
Okay, so mostly the laser diode comes with like the Gaussian and flat top distribution. Okay,
Yeah.
so that means like if we are using one whatever our the x value, if x1 is a gauge and second one we have to put the values. I have personally like checked adding the
Mhm.
value, selecting the gauge 1 and gauge 2 does make the difference at the simulation.
Yeah.
Secondly, that delta x value, delta y value, hx, they also like add, but like where I try to get the information like how exactly these values are defined. Now there are
Mhm.
many confusion in the literature. Like someone is like just define the predefined value. Someone one is getting these values from the Meyer data. Okay,
Mhm.
from the
Yes.
Meyer, like whatever the beam shape they have, then the Meyer FWHM, and then they get it from delta X from there, and these all these things value. So there are like to be more accurate, I think my point is we had to know about these values better to be more accurate and to get have more perfect simulation of whatever the laser diode given to us, and then we
Yeah.
can perfectly simulate. This is the
No,
one point.
I
No,
will, yeah, yeah,
Gigi.
I will
Okay, so
provide the data. I will provide
okay.
the, sorry, parameter and what it defined. Then I
Mhm.
will send it to you that this is
Sure,
its
sure.
meaning. And according to that, you can give me the parameter or you can put it in the file. I will
Sure.
send you that, which I have found out
Oh,
from different sources. And I
yeah.
finalized, okay, this thing belongs to this. So we need to put value of this thing here. So I will
Oh,
send you
okay.
that.
So Mudassar, no, we are like getting the point of where we like having a productive thing out of this, like why we are doing this. Because this shaping system is good to go, like being used for all systems. No, if
Yeah.
we make this shaping system more compact by the placing waveguide with micro lens arrays, very
Okay.
seldomly done by the researchers. So if we replace this, know that micro lens array, I will share that file with you later, the catalog of that lens. I am like they have some vertical gratings in it. Okay, the cylindrical lens, but the grating lines. I'm not sure
Okay.
in the ZEMAX can we simulate that lens like in non-sequential mode, the grating lens inside the ZEMAX. Can we or not?
But I have to
They
check when
have
you show
grating lines.
me. Yeah,
Okay, I
grading
will show
lines.
you.
I think we can define them, but we have to see how we can do that. In non-sequential, we can put the grading kind of thing in every order, like a splitter or something, whatever you want. But we will see
So,
how what are these. So I
so
will then
yeah.
I can say
The
something.
point is that if that could be done, I will
Mm-hmm.
share that data. If that could be
Mm-hmm.
done, then our like beam shaping system is like more compact, and then we will say, okay, we particularly use this beam shaping system to pump the crystal, and we have a better homogenization of pumping system, which definitely increase the beam quality of the system. Okay, we will like virtually will do it, simulate. We will simulate that one, and then we definitely have a theoretical results. That one is the waveguide. So we will
Mm-hmm.
compare the theoretical results with the micro lens array system, the grating
Mm-hmm.
lens. That will be like it's like because it will become compact. The waveguide is about 60 mm. Okay, but the
Mm-hmm. Okay.
lens will be maybe like 2-3 millimeter of thickness. So it will make it more compact. Okay,
Yeah,
and
we can try it. We will try that. It's
so
not a
that
problem.
will be like our something is new coming out of our this research point of view. So this is the way we could go ahead for simulating this shaping system and then converting it into the productive output, some kind of. So I will share that lens to you, and today I will share that paper as well to you, like with Satyab and you people as well. You can like go through it. The one we
Okay,
are
I
writing.
will. Yeah,
Okay.
for timing,
So
I was
you,
just interested to show you that this thing. So if it is okay
that's
for you,
good.
then
That's
we
good.
can
Like you
move
get it like
forward.
most of things. Yeah, you got most of things like you understand most of things. That this is good to know. And like with continuous discussions, we can improve and we will definitely further improve all this. So thank you so much
Okay.
for this.
Okay, Mudassar.
Okay,
Okay.
Okay, Mudassar, thank you very much.
thank
And
you. Gazanfar is
let's
not here.
who? Zanfar is here, but now let's ask David. I mean, David, are you there?
Okay, just a sec.
Yes, I'm here.
Okay, I sent the link after this meeting. Actually, we may need some more, maybe 30 minutes or more.
Mhm.
Okay, so in the WhatsApp group, you can see the link as well. So, okay, David.
Yes, sir.
So, yeah, David.
Oh, okay. I'm
Yeah.
going to
Yeah.
share.
Yeah.
You can see my slides. Okay. Well, I am working on the flash leader on analysis on ANSYS ZEMAX Optics Studio. Initially, we have this setup. I try to simulate, in this case, in sequential mode, but I have
David,
some.
David, just a minute. Can you please, I mean, update, I mean, if you have done something which Mudassar last time asked you to do something like that spectrometer kind of stuff. Not
Yes, I do the spectrometer.
because we don't have that much time. So this LIDAR, I think you have so many things here. So probably if you can present that one, if you have done something there, if you can,
Okay,
if you
okay.
could reproduce something.
Yes. Well, I have this problem that I cannot show the 2D layout because it's not an actual system. This was my setup, and I can have the in the 3D layout the dispersion of the wavelengths, and I have the 2D spot diagram and the modular transfer function. But and the next steps I'm going to follow the Mudasir tutorial on making a diffraction gradient. The diffraction gradient that he is making is different that I'm going to try to do. First, I try a diffraction gradient of 1 dimension, and then I'm going to try to simulate a cross gradient of 2D dimension for getting this pattern. I tried to use the file initially in the tutorial, but I have this error in the length. And they show me the error that I have not actual system. I'm going to try to replicate length by length.
Did you?
I don't know why.
David, did you receive that Nabeel sent you the software or not? He shared with you the correct.
Yes.
This
Yes,
is
this is the
this is that
this
one?
is the software.
Okay.
Yes, is that one
Okay.
because I have here. You can see the software.
Okay. Mhm.
Yes, he helped me to do the software, and I can do some the fabric perot interferometer.
Okay.
Oh, well, okay, let's see. Okay, this was the for my own. I follow the tutorial. Wait, it's going to open. Okay. And this is the tutorial that I follow. I can have the two cylindrical lenses or concave, and this is a little tiny space between them. And when we radiate a green laser, and we run the physical optic algorithm, we can have the irradiance, the pattern typical for the Fabry-Perot interferometer. So the next step, I'm not expert in the software. I'm beginner. I try to follow the tutorial that is uploaded in the group. This tutorial is about the diffraction gradient, but this diffraction gradient have a different pattern that I am looking for. That is the cross to the pattern. This pattern forms when you cross a diffraction gradient to an angle of 90 degrees. And that is all for my
Mudassar, can you
my
please?
side.
Come up. So David, actually, Mudassar mentioned to you that spectrometer, his article. So you didn't try to reproduce that data? Last time you mentioned that you worked on it, but because you didn't have a software, the correct one, that is why. But you didn't.
Yes, I only did the Fabry-Perot interferometer.
You didn't do that one.
I do that one.
Yeah, much
in
better.
the-
I mean, so we can. I think better to go some through proper channels systematically, because if you touch so many things, then you cannot conclude anything. So take one thing and continue work on that thing. Okay.
Yes,
So yeah,
I'm
this is
going
much
to
better. Yeah.
Yes, I'm going to continue to follow the tutorial of the diffraction gradient, and then I'm going to try to replicate first this diffraction gradient in 1D, and then the diffraction gradient and cross in 2D. When this is the cross grading pattern, and then I try to get this setup in my ANSYS ZEMAX.
Okay. Okay, Mudassar.
Okay, you can try that when you get a little bit familiar with them. We will see how thing. The flash radar system which you have finalized, if you can send me you can say a rough layout on a paper, or you can send me some file in which we have that layout, then I will see how to design the flash radar and how we can improve it. So let me know if you have something finalized on a flash radar or radar system that we want to simulate on a ZEMAX. Let me know about that, because
You want to
because I did not
you
get-
want to show something regarding the LIDAR?
Yeah,
David?
if we have some layout, sorry, so he's asking.
No, it's okay, Mudassir. Yes, I'm the. Maybe I want to try like you do in the Fabry-Perot interferometer. First, you put a lens, and then you get the layout, and then the tree layout. Open the windows in the program. Because this time I tried to open the table, but this don't work. Maybe because the tutorial was in a newer version, and I have an older one.
No, I'm saying that is okay. I'm saying if you have some finalized some flash lidar system or lidar system which is typically optical based, and we want to try that in the future, then let me know if you have finalized something regarding that. Like this
Okay,
is-
okay.
Yeah.
Okay, Mudassar, much better to finish first with the Fiasab's matter. So after that
Yeah,
you
we
can.
will see.
Yeah. So
Yeah.
meanwhile, I think David can practice this
Yeah.
ZEMAX stuff, and it's much better if he can streamline himself. I mean, take one
Mhm.
topic and continue work on it.
Yeah,
That would
that will be
that
good.
would help him to be get aware with this ZEMAX.
Yes.
Yes, David.
Yes, I think.
Yes.
So,
Okay.
yeah.
So we are going to change to the next meeting
Yes,
because
next meeting. Yes.
remaining.
Yeah, stay there actually. I will send. I already sent the link, so I will finish this meeting. Okay.
Okay.